Hey, everybody, and welcome to another episode of Elixir Mix. This week on our panel, we have Mark Ericksen.
Hey, friends.
Josh Adams.
Boy.
I'm Charles Max Wood from devchat.tv, and this week we have a special guest, and that's Francesco Cesarini.
Hi, everyone.
Now, you are the, if I remember, the CEO of Erlang Solutions.
So I'm the founder and technical director.
Okay.
I'm more technical in nature, so I prefer to kind of take on someone who can do the CEO role.
Okay.
Yes. So
since you're the technical director, and before we get into what Erlang Solutions does, I have a burning question. Is it Erlang or Erlang?
It depends on your. it depends on if you put on a Swedish accent or an Italian one or an American one. Everyone's right and no one's wrong. So It just depends on who uses it. I think if you want to go back to the origins, you need to go back and ask a Dane how they pronounced Erlang. It's Agnikarp Erlang. It's a Danish mathematician.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code devchat at Sentry.io to get 2 months free on Sentry's small plan. That's code devchat at Sentry.io. Okay, well, do you want to just give a brief introduction to who you are, what your background is, and what Erlang Solutions does?
So I'm Francesco. I've been, I kind of made my way to the computer science lab at Ericsson when I was still a student. Fascinated by, what at the time was a language which had just, been released by Ericsson. And, I've been working with the Erlang ecosystem for the last 25 years. In '99, I founded Erlang Solutions. So we're a professional services company focusing around the Erlang ecosystem. So everything from development and support of Erlang, Elixir, and Erlang and Elixir specific stacks. So we do a lot of work around RabbitMQ. We're the main drivers around Mongoose AM, so an open source instant messaging platform. We do a lot of work with React, the distributed NoSQL database, as well as run events. So CodeBeam in San Francisco, CodeBeam in Stockholm, Code Elixir in London, and we also co-run together with Jim Freeze, Elixir EU. And we also provide support around the virtual machine. So we've got people who are working on the Ericsson core team on the VM, and all in all, are enjoying it and having fun. It's been a fascinating ride, seeing Erlang go from a programming language to a kind of fully fledged ecosystem with tools, and I think we've got about 15 languages running on the beam right now. So it's not just about Erlang and Elixir.
I think Mark was chomping at the bit to ask you some questions about what Erlang Solutions is doing with Elixir.
Well, I know you guys are like a consultancy also. Like you mentioned a lot of the different things that you're involved with in the community, the projects that you kind of shepherd. But so if I'm an Elixir developer and I'm perhaps new to an Elixir language, is Erlang Solutions something that can actually help me? I think that's a question people might want to understand.
So what we've done, what we do is basically help companies, startups and enterprise alike, with the adoption of Elixir. So and we take them the whole journey. So usually the adoption starts with a proof of concept, where we will go in and work with the customer on a proof of concept to make them decide if Elixir is or is not the tool of choice. From there we, in parallel, and at the end of a proof of concept, usually do a go no go decision. Will I base the product on Elixir, yes or no? And if they do, we've got training, so we'll go in and start training the team. We found that the productivity increases much faster if you have proper training versus classroom training over a few days versus self-learning. Mm-hmm. And if it's needed, we'll embed people in together in the project together with the customer, and slowly try to phase ourselves out and remain available maybe for third line support. We also have a tool which is based on around 20 years of operational experience of the Beam, which is called Wombat OEM. And this tool will provide about 25 alarms, metrics, and notifications basically on the Beam itself. And it's there to prevent outages. So focusing very much on non-stop operations.
Yeah, I've seen Wombat and it looks extremely cool, but I haven't had the opportunity to play with it.
It can be overwhelming at first if you're not used to it, because you get 200 metrics and you wonder, you get activities on a per core basis. But if you're a WhatsApp, handling billions of messages per day, that's what you need, to troubleshoot outages when you're in fact, it's like looking for a needle in a haystack.
And I think that's something worth mentioning again, is that that WhatsApp is also on Erlang, and so I think that's neat. Just that you're talking about something that works at that scale, and that Wombat OAM is something that can support kind of the running and maintenance of a system like that.
Well, it's yes, and it's based. Most of the lessons learned were from the telco space, where you just expect the system to work, and the only way you can expect the system to work is by going in and actually, catching issues before they escalate and cause an outage.
Yeah.
So it's you have to be paranoid to really run a telco network and make sure nothing fails.
It's true. It's not something I want to take on.
Wow, what a great segue. We brought Francesco on to talk about scaling and resilience, or fault tolerance, I think is another term that we've seen.
Yes.
I
do want to get into that. And one question I had.
Dang it, Mark. No, I'm just kidding. Go ahead.
Now I forgot it. All right, we'll just jump in. No, okay. Yes, I remember. It was just, the question is, what was, like, from your perspective, you've been in the Erlang community for a long time. Elixir is a very new up and coming kind of language, and it's kind of, I don't know, brought a lot of different people into the Beam kind of environment. What has that been like for you to kind of witness that and see that? And then now there's this new set of clientele that you can perhaps help. Like, what's that been like?
It's been absolutely fantastic. What Jose and the whole Elixir community have bought is a different mindset and a different approach to doing things, and a very complementary set of skills, compared to what we in the Erlang community have. If you look at at the risk of generalizing, but and I don't want to generalize, but if you look at your typical Erlang developer, they'll go in, they'll love, complex algorithms, and, they'll program distributed systems, and they like to solve kind of really, really hard, complex problems, telecom protocols, and diving into the whole SS7 stack and whatnot. And they, but without any major thought kind of on the whole user experience and usability. It's plumbing, it's server side, back-end infrastructure, mm-hmm. which is just expected to work. And I think my first kind of recollection of actually beginning to socialize with the Elixir community, I think back in the very, very early days, I think we provided a track. I think a year before Elixir Conf actually started at the Erlang factory in San Francisco, just focused and dedicated to Elixir. And in doing so, I remember being struck by the focus the Elixir community had, which was on, UI, UX, usability, user interfaces, looking at user-friendliness. So a whole new set of items which the Erlang community wasn't able to handle. And so it was two completely completely complementary skill sets, which needed to be merged together to really get the best of both worlds. And that's what really I think made me that's what got us to start expanding what at the time were Pure Erlang Master Erlang Factory, rebranding them to Codebeam, with basically the mantra that I think there are two communities out there which have a lot to learn from each other, and come in and listen to each other's talks, and we've seen how both have affected each other really, really positively. At the end of the day, I think Erlang and Elixir are completely interchangeable as programming languages, because a language at the end of the day is not the syntax, it's the semantics. There are a few constructs you might have or might not have in one language or the other, but they're interchangeable. But the types of problems which they're being used to solve are intrinsically different. So what this has done is it has brought in a whole new set of problems and facilitated other problems we were trying to solve in the Erlang world, by kind of getting the Erlang side to create better tools, to create better infrastructure, but at the same time it's helped the Elixir side to go in and start creating architectures which actually scale. So going beyond the typical Ruby on Rails, I'd say, architecture, where you've got your web servers, you've got your database abstraction layer and Postgres, to actually something much more complicated. So I've just the kind of positive influx has been on both sides, and it's been fantastic. And it's really thanks to Elixir where we finally realized that Erlang was becoming it wasn't a programming language anymore, but a whole ecosystem.
Well, that's awesome. I really appreciate you sharing that perspective.
Yeah.
So as Chuck was really trying to do, I'm going to let us do now, which was, I'm excited because we have you to be able to talk about scalability and reliability. And it is some of those features that come with the Beam that, like me, I'm newer to Elixir. I didn't come through with the Erlang community. I've been using Elixir for about 3 years. But, so scalability and reliability are something I really appreciate and I value. And that is something that I get like in a lot of ways for free with the Beam. And I'd love to hear kind of like if you could kind of start introducing this topic to us.
It took me 20 years to realize why Erlang and Elixir, by default, was both scalable and reliable. Until then, if I were to ask you all, why is Elixir scalable? You'd all give me 3 different answers. And if I were to ask you, why is Elixir reliable? You'd probably ask, oh, because of OTP or some other answer. Because it's not easy to actually figure out and really understand. And it actually took me 20 years until I had to prepare a talk for, I was keynoting at the Functional Conf in India. And in doing so, they asked me to talk about the functional properties which influenced Erlang and Elixir as programming languages. And in doing so, that's when I finally realized that the key to both scalability and reliability starts off in the programming language semantics themselves. So you've got processes in Erlang, and processes don't share memory, and they communicate with each other through message passing. So basically, it's concurrency based on immutable state. And if you think of it, there are 2 ways to do concurrency. One is the traditional way, which is based on mutable state, and that's threads, shared memory, and locks. And in the Erlang ecosystem, so Erlang and Elixir, we use immutable state. We use processes, no shared memory, and message passing. And it's the whole no shared memory which is the key to providing this property right here. And if you think of it, if you think of mutable state. So if you think of threads, shared memory, and locks, if your process crashes when you're executing in your critical section, so in shared memory, you basically need to terminate all processes all threads which have access to that shared memory, because you do not know in what state the shared memory was left in when that thread crashed. And the second problem with mutable state is locality. You've got a thread running in London and a thread running in Colorado, so in Denver. Where do you put your shared memory? Where do you locate your shared memory? All of a sudden, you've got latency. You've got, assume you decide to put it halfway, so say in Iceland or Greenland, you now need to access that shared memory, and that adds, time. But most importantly, what happens if your connectivity, towards your shared memory goes down? And it's not an if, but a when that's going to happen. The only thing you can be certain about when it comes to networking is that you will get a network failure. And so shared memory is great if you need to write super fast programs that will work, but they will only work on a single machine. For simple code. And by simple code, I mean a code where you assume that nothing goes wrong. If you look at the Erlang approach to concurrency, if a process crashes, your state will not get corrupted because each process will have a copy of its own state. So what you do is you just lose the state of the process which crashed, but nothing else around it is actually affected. If you look at locality, you've got two processes. If you've got a process in Denver and you've got a process in London, you don't need to locate state anywhere because you copy it. So you don't need to put any data in Iceland or Greenland. They'll each have their own copy of the data. And if the network connectivity goes down, your process in London and your process in Denver will still be able to continue running independently of each other. And what you need to think about, however, is when the network comes back up, is creating consistency among these two processes. So that is, I realized, when giving the keynote, was the key to both reliability but also scalability. And what we do is we've got a virtual machine which has two features. The first feature is, which are critical here. The first feature is that it's highly optimized for large-scale concurrency. That means you can have millions of processes running in your VM at any one point in time. And the second is, and what you can then do, thanks to distribution, is go in and spread these processes across multiple machines. And what distribution does is it abstracts away from when things are executed, but it will not slow down the computation. All it does, it will slow down the computation through latency, but it will slow down one single computation. And if you start thinking of it, you start doing hundreds of millions of computations in parallel on multiple machines, that's when you get your scale. And you can do that completely transparently because either you have a million processes running on a single node, and if you run them on a single node or on hundreds of nodes, your business logic, your program is still exactly the same. It won't change that much. And so that's basically that is the key. But and that's how you go in and now scale horizontally. But there's another thing which is scaling vertically, and that's basically has to do with multi-core. The biggest issue to scaling on multi-core architectures is memory lock contention. So what you do, you pick a programming language which doesn't have shared memory. So that means Erlang and Elixir, and that's how you now get. You obviously need to think slightly differently. You need to think in terms of avoiding bottlenecks. But you still get now vertical scalability where you can actually start utilizing all of your cores without, with none or minimal changes to your business logic. So what that does is basically, we've got immutability, which gives us concurrency. So a concurrency model with no shared memory. That concurrency model with no shared memory in turn gives us the distribution where we can distribute load on multiple machines. And that distribution will give us two things. It will give us the scalability, because we distribute computation on a lot of machines, but it also gives us reliability, because all of a sudden we can have two copies of the data of two separate machines. A machine gets struck by lightning, the other machine has a copy of the data, and it can still continue executing. And together with multi-core and distribution, we then get parallelism, which allows us to now go in and scale vertically. So that's the secret sauce behind it. And what to quote the co-author of my book, Designing for Scalability with Erlang OTP, you distribute, Steve Winovsky, he said, you distribute for scale and you replicate for availability. So you will copy your data for availability, but you want to distribute on many machines to achieve scale. And the Erlang VM has all of these features built in, which really facilitate the way you can think and reason around all of this.
Yeah, one thing I think is really interesting about it being a property of the virtual machine rather than a sort of a bolt-on library, say, if you were in, I don't know, another language, C, is you know that the library ecosystem has to also adhere to this no shared memory, because there's not an option not to. For example, in Ruby, I very frequently would pull in libraries that had shared things that messed me up, and I ended up having to fork them. And I can't have to do that in Erlang.
Absolutely, I completely agree. And I think if you were looking at one of the major selling arguments to using Scala was Akka, which was a great invention. It was a great library, but the biggest problem you had with Akka was all of the other libraries you were bolting on and using. Say, hey, use Scala, you have access to all of the libraries on the JVM, which all of a sudden started using shared memory. and so, so hey, what's the point? And I think, to quote Joe Armstrong, you can copy the libraries, but if it doesn't run on the beam or on well, he used the term Erlang virtual machine, you can't emulate the semantics. And so, you can definitely use Akka on the JVM, but it's going to behave very differently from actually running things on the beam. And the reason, again, is the beam and the JVM were built for two completely different things. And I think you said something really, really important. A scalability and reliability is not something you can bolt on as an afterthought. In a programming, the same with concurrency, obviously, but the same, and be that a programming language or any software architecture, you need to design with scalability and reliability, from day one.
Well, the thing I think is interesting about this conversation, especially around the scalability and reliability that's built into the VM, it's not that you can't necessarily make scaling work on other systems. I mean, I've done a lot of Rails. You see Rails scale up to huge applications.
Absolutely.
The difference is that you don't have any guarantees of the things that make it easy to scale in Ruby the same way you do in Erlang, because it's not built into the VM like you're saying.
So what you say is perfectly correct, and you can scale any programming language. Yes. All you need to do is throw more hardware at it. Mm-hmm. And again, Erlang and Elixir are not the fastest programming languages out there by far. But what these semantics do is they really facilitate, the way you reason around your programs. So you need to start thinking. You need to think differently when you're architecting your systems, and they really facilitate the way you're able to reason around it, and remove a lot of accidental complexities which you would otherwise have with other programming languages. So with very little change by doing it right from the start, you can achieve a certain level of scale, and very, very easily and we've seen Phoenix handling 2 million simultaneous open TCP/IP connections on a single machine, and that again is possible, thanks to each connection being represented by a process. So the programmer just needs to think in terms of one single request, coming from a WebSocket, and the workflow for a single request, and then automatically the VM will scale up for you.
So I guess maybe when we talk about scaling, we're talking about two different things then, because a lot of times we're talking about scaling, and a lot of people see scale and they think size, right? I've got a giant app that handles thousands and thousands and thousands of requests, if we're talking about a web app.
Yeah.
And what you're saying is that when you scale, instead of thinking of it that way, you're thinking the micro case, the one thing, the one process, the one request.
The single user, yes.
It replicates as many times as you need it to. And so the scale, the small scale is the same as the large scale. And so that makes it easier to approach.
That is correct. That is correct. And in probably 99% of the cases, all you need are two nodes, to handle it for redundancy, because most of your traffic, will be handled on a single node, and most nodes, can handle tens of thousands of requests per second, depending on the hardware.
We've at work, we've just rolled out a Kubernetes cluster, and we have a Rails application, and we have several Elixir applications all inside this cluster, and they're kind of integrated services that talk to each other. But it has been so painful to get the Rails thing to scale. Just like it sucks up so much RAM, and it's like CPU is like pretty high, and it's like not doing hardly any work. And when you think of like what it's actually accomplishing, how many users it's actually servicing at the same time, and like then you look at the Erlang Beam ones that are Elixir, and they're like chugging along, handling this incredible amount of load and incredible network traffic, and
5-10% CPU, if that. Yeah,
exactly. Yeah, they're like at 20% CPU, and the RAM is like pretty steady, and it just doesn't budge. It's like it's so much nicer.
Yeah, well, I mean, to be fair to Ruby, Ericsson has had an amazing team of engineers just focusing on the VM for the last 30 years.
Yeah.
So, and it's highly optimized for exactly this, and it's, yeah.
And I don't mean to bash on Ruby. I don't, because
no, absolutely,
Ruby,
absolutely.
When Ruby was created, it was created with a different idea in mind. So
exactly.
One of the things I want to come back to is something you mentioned earlier, is that these fundamental principles have to be built in from the beginning, and you can't bolt it on as an afterthought. And like if you could speak to that, because I know like there are people who be at Ruby and they're saying, oh, we want to Elixir's popular, maybe we can add pattern matching. Well, pattern matching is not the whole thing, right? That's
no.
And or if it's Java, or if it's Rust, or any of these other languages that are kind of newer and popular, but yeah, like
so it's and you're asking someone who's really conservative about adding new features to any language. My view has always been, if you add a feature, remove one, because languages have to be simple. You need to have as much simplicity as possible, because that's critical when it then comes to maintenance of systems. And it's true, you just cannot add, there are a lot of things you cannot just add as an afterthought to the programming language. Pattern matching just changes the whole programming model and the way you structure programs. And well, what it adds is it basically gives you more concise, shorter, more readable, and easier to maintain programs. That's what it does. And the same with pattern matching on the bit syntax, for example, which again
it's more efficient too.
Exactly. But again, efficiency has never been the key.
No. Yeah.
The key part in programming Erlang or Elixir. It's I think the key parts here is programmer productivity and low maintainability. The cost of low maintainability costs. And we were talking about WhatsApp earlier. I don't think we in the Erlang community have been very good at kind of showcasing how you increase programmer productivity and reduce maintenance costs.
When they were acquired for a crazy amount of money, they had 40 engineers.
No, that's incorrect.
40?
They had 10 server-side engineers.
Yeah.
They had 37 engineers, of which 10 were server-side, 27 were working on the mobile apps.
That 10 people managed WhatsApp traffic.
Yeah, no, and again, you had 10 people developing all of the new features, maintaining all of the existing features, and supporting the whole backend infrastructure. So it's the same 10 people who were doing absolutely everything. And they were the ones being woken up in the middle of the night when there was an outage. And guess what? Very rarely was. And when there was, it usually wasn't because of any of their faults. So so it's and they were the ones who actually went in and advertised it. Even 37 sounds incredible for a company which when they were acquired were sending 2-3 times more messages per day than the total number of SMSs in the whole world. So and that was it wasn't until WhatsApp got acquired that these numbers actually came out from an independent source. So the biggest and best thing was actually getting them to showcase the business case for Erlang and Elixir, because obviously no one would listen to us when we went and told the world that you're more productive. Everyone says the same thing, but $19 billion I think spoke for themselves.
Yeah, I feel like the operational happiness aspect of Erlang's focus is also overlooked very often when I see people online sort of discussing it, seeing if they want to get into Erlang or Elixir. All the time I see them going to, I don't want to say micro benchmarks, but CPU focused benchmarks.
Yeah.
And like, yes, if you put C up against Erlang, it's not running on a VM, it'll be faster. But
of course.
That's not my concern at 2 a.m.
If you need to write very, very fast code, if you need to do number crunching, don't use Elixir, don't use Erlang. Use
Erlang and Elixir to orchestrate it.
Exactly. Control it, orchestrate it, aggregate all of the results. Exactly. And then use C, Rust, or Haskell, or whatever natively compiled language you'd like to use. And micro benchmarks are completely irrelevant at the end of the day.
And yet they seem to dominate the discussions that I see online when people are evaluating languages.
They dominate the discussions of those who don't really know what it is of those who like to compare apples and oranges, I would say.
Well, the other thing is that, if the forcing factor of a budget of a business that ran on software were CPU time or memory or things like that, then everything would be written in C and Rust.
Absolutely.
But the reality is that the forcing function for software-based companies is their personnel.
Yes.
So they're going to use languages like Elixir or Erlang or Ruby or JavaScript or Java or C# or something like that, because it is easier for the software developers to reason about, and they can get more work done in it, and that lowers the cost of getting the software developed.
Absolutely. And there's one thing when you're talking about lowering the cost, which I think Erlang was the first, and it's now being copied in a lot of other places, which is OTP. So obviously Elixir as well, because again, we started off by talking about kind of the language semantics, which are then implemented in the VM, which then give you this level of reliability. But using these language semantics, you can then build frameworks on top of it, which abstract a lot of the common issues which occur.
Can I have you define OTP real quick for our newer listeners?
So OTP is, I would call it the middleware, which hides all of the tricky parts involved in concurrency when it comes to concurrency. So it hides, let me give you an example. You've got process A sending a message to process B. And when you're sending this message, a lot of things can happen. Process B can fail before you send the message. It can fail after you've sent the message, but before the message is handled. It can fail whilst it's handling the message. or it can fail, right before sending back the response. So these are all kind of patterns which you need to cater for, because again, it's software, there will be bugs in it. And what OTP does is it handles all of these issues which can occur. So this is one example, but there are many. When you're dealing with concurrency, you're dealing with deadlocks, you're dealing with, there are a lot of tricky things to it. And what OTP does is it abstracts away a lot of these issues, handling them for you behind the scenes. So you basically get some processes which take on a particular behavior. And the most common behaviors will be generic servers or client servers. You've got finite state machines, which I don't believe are used that much in the Elixir space, but in the Erlang world, they're everywhere. You use them for telecoms, you use them for complex protocols. It's a way of simplifying the code base of a generic server, client server. You've got event handlers, and you're getting new behaviors as well in Elixir, which are now being ported over to Erlang as well. And all of these, all of these processes, we call them workers. They'll go in and basically handle requests in a particular way. And what they do is cutting the code base drastically. Now, all these processes are then handled by a supervisor. They're managed by a supervisor, whose task is to start them and monitor them. And so supervisors will, what a supervisor does is, you've probably always heard us use the let it crash mantra, which will scare away managements, because they think of crashing being something bad. But in fact, what let it crash means is that you delegate the handling of errors to your supervisor. Don't try to solve bugs or corrupt state in your codes. Instead, terminate your process and let your supervisor deal with that error. And what it does, it will deal with it in a standardized way across your program. So what you're doing is you're removing the responsibility from the hands of the programmer into the hands of an architect who will think about the supervision strategy. So, whilst people say let it crash, they'll think, oh, we don't handle errors. That's wrong. We handle errors, but we handle them in a different way. And so OTP will tell you how to go in and architect everything in a single node, on a single node. Creating levels of escalation and recovery strategies, which are built into your program without you even being aware of it.
This episode is brought to you by Triplebyte. Applying to programming jobs sucks. You have to put the right keywords in your resume. You spend hours and hours on the phone screens and take-home projects, and that's assuming the company even responds to your application. Well, if you're a software engineer, Triplebyte can help. They work with over 400 top tech companies, from big names like Dropbox and Adobe to exciting startups. You do one brief online interview with them, and if you do well, you go straight to final interviews with the company on their platform. It's like the Common App for software developers. Triplebyte does not look at your resume or where you went to school. All they care about is if you can code. I've helped dozens of software developers with various credentials get jobs, and this looks like a terrific way for you to get in and get interviewed and get a job without a lot of the hassle and overhead. You can go check them out at triplebyte.com/elixir. That's triplebyte.com, byte as in 8 bits. As a special offer for listeners of this show, if you take a job through Triplebyte, they'll offer you a $1,000 signing bonus.
So that was the elevator pitch. It was a very long it was a very kind of tall building we're getting up into, but that's basically the real power of OTP. And again, it takes years to realize it.
One of the other topics we've kind of mentioned was immutability, and I run a meetup, and so we have a lot of people who are new to the community, and these are people who are they're familiar with object-oriented programming kind of things, and they really struggle with the idea of how can you actually do anything with immutability, and it's made me have to kind of pause and kind of think about how I can better explain this. But I mean, it is such strength that comes from the immutability, and when I go back to and work in other languages, I really miss it.
What I've learned is when you get used to immutability and then you go over and program in other languages, you tend to bring immutability with you and you force it on yourself as in your programming style.
Yep. And then your coworkers hate you. Because they don't understand it.
yeah. But it's and often, we've always said, I think we tend to we heard it a lot that, programming Erlang is hard, and we used to get it a lot back in the days, and the hardships were not so much learning to program Erlang, but it was actually unlearning everything you had learned with your previous programming languages, and you had to change the way you think and reason. And the same applies to Elixir. Mm-hmm. Even though what Jose has done is he's been very good at kind of hiding the fact that you need to think differently until it's too late, and you've basically you're past the halfway mark, so you're returning back to go with will take you more than actually continuing to the end, and it requires a different mindset, different way of thinking, and but once you get used to it, it actually becomes a very natural way of thinking, because it kind of reflects the world around us, and this is then directly applied to the whole notion of to the concurrency model as well.
I just want to explain kind of what you mentioned there, like it reflects the world around us. I've heard Joe Armstrong talk about this, and it's a concept I think I just want to make sure you, our dear listener, understand, is that like if you think about people, a person really maps very cleanly to a process in terms of how a process works. It has its own internal state, like how I think, what is in my head, you don't know unless I tell you by sending a message. Like, this is how our world works. We intuitively understand this. And so when you come to Elixir, you don't see that right away. And yeah, the world is concurrent. Like, like everyone is like running along in their own little cars, doing their own little thing, their own little world. And we're just like sending messages to each other to say, hey, I have this task for you to do. Can you help me out? Or how did that go? What's the result of this? That's what we're doing. And so it is truly like how the world works, and it's how the beam works. And so once you kind of grasp that, then it becomes natural. You kind of said that and just let it slide right by. It's like, no, that's a gem. People need to catch on to that one.
And I wanted to add a fourth thing, which is basically shit happens, things fail. Once we're done with this podcast, I could, walk out on the street and get hit by a bus because, as you know, here in Britain, they drive on the wrong side. And we hope it doesn't happen, but if it does happen, you guys will continue with the podcast. And so things continue. And so, model a programming language around this. And so, it's a natural way of thinking, but it's not, for many people, it's not a natural way of thinking when they program. Mm-hmm. But it takes very little to get used to it, but one needs to, push themselves to actually start thinking concurrently.
Right. And that's what you were talking about earlier, right? If you get hit by a bus, you don't have to restart all of us in order for the world to keep going.
Exactly.
Reboot the world.
The podcast continues, and someone else will hop in to replace me. And that's just the way Erlang works. Thanks to the no shared memory approach. So that was a very good analogy. One thing I wanted to add also is that thanks to OTP, writing and architecting everything, you're able to write frameworks, which it's much easier to write these frameworks, which give you the distribution and the fault tolerance, and the simplicity also makes it much more easier to maintain. So we look at the scalability, but we look at the fault tolerance. It originates from kind of the language semantics, which are then implemented in the virtual machine. The virtual machine will then affect the programming language themselves, and then the libraries, the generic libraries which you write on top of it, are much easier to write, which you then use as a programmer. And so all of these levels, have fault tolerance and scalability in mind. And they had fault tolerance and scalability in mind when they were developed.
So how does this translate into the frameworks then?
What do you mean? Could you rephrase the question? Okay.
A lot of the work that I see done in Elixir is Phoenix. I mean,
Yes.
we also see it in like nerds and things like that. So there are these
Exactly.
different areas that this kind of, where we've got Erlang, and then we've got OTP, and then so we've got these things stacked on top of each other, right? And at the top level, the things that I'm building usually have 3 or 4 layers underneath it.
Of abstraction, exactly, yes.
So how does this affect the world that I'm working in? Because I'm not writing OTP, I'm writing Phoenix, or I'm writing nerds.
Exactly, you're writing
process to do a thing, right?
Okay, perfect. Yes. So what this does is it makes these frameworks, it becomes much easier to write these frameworks. So if you start thinking, you start implementing, tons of different endpoints. Or what happens if there's a bug in your code, the particular process handling an endpoint will terminate, but none of the and the supervisor will catch it, and most likely just go in and close the WebSocket. So and it won't go in and affect any of the other endpoints which are being handled concurrently. You go in and you lose a thread in Java, all of the requests going through that thread will be lost, and the same applies to Python and other languages. So that is how that is how these frameworks facilitate it. So you just don't see them; they're there, and in some cases there will be cases in Phoenix where you will have issues with processes crashing and then automatically being restarted, and most likely you as an end user, and even the end users won't see it, and won't see that happening. So I don't think. It would have been possible for Chris to implement Phoenix to the level he got it at without OTP. It's kind of built into how you architect your system.
I was going to add, also you get access to all of the power of the Beam sort of inherently. So you mentioned yes. Phoenix and WebSockets. So if someone opens a channel and you link something that needs to happen while that user is connected, and they disconnect, there's no cleanup, it's linked, it's going to go away because the WebSocket disconnected, and so consequently it gets the message to die.
Yes.
So you don't have to do, there's this whole level of cleanup, and would you even think to do that cleanup, or would it, would you think to do it later when you realize that a bunch of stuff was still running and sucking up memory, and had to figure out what it was. Again, the operational happiness. The developer just follows the very normal way of writing Erlang programs, and you get this property of the system, which is the resources used by a connection go away when the connection's gone. And that's not something you get for free in other languages.
Exactly. And I think the beauty of it, all of this happens without you having even to trigger the garbage collector, which I think is because all of the memory used by that process when that process terminates is freed automatically.
Yeah, this isn't an academic thing for me. This was literally a problem when I wrote an actor model-based system in Ruby.
Yeah.
This the thing that was very hard to get right and is basically impossible to get wrong in Elixir.
Yeah, it's basically it's the here is you need to write a massively concurrent system, use the right tool for the job, and the right tool for the job is one which reduces accidental complexities.
By having the semantics of concurrency built in at a fundamental level. Exactly.
So that by avoiding accidental complexities, you can then focus on what is really, really hard, which is the business logic of your system, and not everything else around it. Let everything else around it manage itself.
Yeah, I think it's too easy to forget that part. The longer I spend in Elixir, the less time I remember that this whole section of things I used to have to be worried about.
Yeah.
So does this apply beyond software?
Well, that's a good question. So if you think of it, you need, for every system which never fails, right? You need at least 2 of everything, and that means you need at least 2 computers. you need at least 2 power supplies. You need at least two, at least 2 network interfaces. Because if you don't, you've got you end up with one single point of failure. And I've got 2 stories here where the first one is I was visiting AT&T giving a guest lecture, and it was the head office in New Jersey, and they go in and say, hey, I was telling about no single point of failure, and one of the engineers points out that, hey, in the Long Lines building in Manhattan, so that was it's this brutalist building in close in downtown Manhattan with no windows. And it was built to house telephony switches. Rumors is, which at the time were huge, were built in the 70s, which housed telephony switches. Rumors today have it that the NSA actually have all of their computers there because it's kind of atomic, it's bomb proof, and it was built to never fail. And
all those telephony wires aren't going to spy on themselves.
Yeah, exactly. And what they said is, in the cellar, we have a tank of petrol, of gas, which is enough to power our generators for 2 weeks. So if there is an outage, if there's an outage a power outage in Manhattan, the phone switches in the Long Lines building will continue running for 2 weeks. Until until either they restored electricity or the power fails.
That is impressive.
And and that's what you need to think about when you're dealing with no single point of failure. Another favorite story is, and again, it reminds you that it's you can do as much as you want to protect yourself in the software, but obviously there are many other moving components. Was a switch which some colleagues of mine were involved in implementing. And the switch had been up and running for 3 years. It had never been rebooted, and it was handling all of the international all of the international trunks for a major carrier in a city with 10+ million inhabitants. And everything else has been anonymized to protect the innocent here, but. What happened is, after 3 years of the switch never having been rebooted, never having without having had any issues whatsoever, and they hadn't even upgraded it, Ericsson goes in and tells the customer that, okay, sorry, but this software version you're running on will now no longer be supported. So what I would suggest we do is we just upgrade to the latest version of the system, and in doing so. This will, however, require a reboot. Yeah, we do have live upgrade, but that would mean free live upgrades, because we'd have to upgrade from one version to the second, from the second to the third, from the third to the fourth. So avoiding free live upgrades, we'll just write some scripts which will migrate the data. We will go in and then just reboot the system. So there won't be any outages because there's, once again, there are 2 CPUs. So we'll reboot the system. The other CPU takes over the load. We start off a new system, move the traffic over to it, reboot the second. And so the customer agreed to it, and they went in, ran the upgrade scripts, rebooted the system, and the machine wouldn't start up, the computer wouldn't start up. And when that failed, they panicked, and they automatically went in and upgraded the other node, which was now the primary node, rebooted it, and that ground to a halt as well. That wouldn't start up either. And obviously you can imagine support engineers who, after 3 years of not having to do any firefighting, ended up, didn't know what to do. In the end, they ended up having to fly over an engineer who couldn't figure out what happened. So about a week later, this outage happened a colleague of mine had 2 new boards hidden in his jacket, in his raincoat, walking through customs in this country, because had they FedExed the boards, they would have been stuck in customs for months on end. Went in, put in the new boards, and got the system up and running. and hey, all of a sudden the switch was up again. So they had to basically change the hardware. And obviously this had reached CEO level communication. So there was a very detailed postmortem. And these systems were running Solaris at the time. And what they discovered is that the Solaris, the boot sectors of the hard drive, are the external sectors of the disk. The system hadn't been rebooted for 3 years. That meant that the head of the hard disk had moved backwards and forwards without touching the external sectors. And so a thin layer of dust in these hermetically sealed nodes basically collected. And when they went in to reboot it, the hard drive, the head just kind of touched this thin layer of dust and ground to a halt and couldn't restart. So this always comes as a reminder that two-hour everything is not always enough. There are lots of other factors you need to keep in mind. When dealing with software, which never fails.
Yeah, so it all came down to hardware failure.
Exactly, hardware failure, which no one could have, which no one thought was would have been an issue back then.
That does sound like a very detailed postmortem. So
yes,
and the fact that the hardware failure relied on the system. I mean, it ultimately came down to the system didn't need to be restarted ever.
Exactly. So ever since there was a patch which got added, which every night at midnight, so when the traffic is usually lowest, all of these switches started doing disk aerobics, and so the head would move backwards and forwards, to spread the dust evenly across the whole disk to avoid issues like this happening ever again. And it was the only time this issue actually ever happened.
Wow.
Yeah.
That's great.
So yeah, you need to think about that. It's just not about software. There are a lot of factors which you need to keep in mind when you're dealing with systems which have to scale but also never fail.
I want to see the function name for the routine that sweeps dust off a hard drive platter.
I'm sure they gave it a Swedish name. A bit look like your IKEA furniture, it's
that makes me want to see it more, not less.
So have we covered this topic thoroughly? Is there anything we missed?
I think we've covered a lot of detail. Yes, there's nothing else which comes to my mind.
All right, sounds good. Well, let's go ahead and head toward wrapping up. Real quick though, Francesco, if people want to find you online, where do they go?
Twitter. My hashtag, my handle is Francesco C. That's the easiest way to get hold of me.
Awesome. All right. Well, let's go ahead and do some picks. Josh, do you want to start us off with the picks?
Yeah, I've got a couple of maybe weird ones. The first one is a link to the Wikipedia page for cybernetics, which my mental understanding of cybernetics was actually primarily concerned with was just way off. But in general, it's systems thinking, and it was defined way back in 1948, and it's super interesting to sort of have this whole new word to dig into in depth that relates to a thing that I like a whole lot, but most books or whatever that are talking about systems thinking in the modern sense are they're going to be different than stuff written in the 50s that was not specifically around, say, computer systems thinking or whatever later. Anyway, so I find that interesting. And then I need to find the link really quick, but Jessica Kerr has an article on, I think it was called, yeah, here it is. I'm about to share it. It's called The Origins of Opera and the Future of Programming. It's an article from last year that she wrote, and it's just a really good article about sort of the groups that come together and make each other better and make a thing that is better than themselves. But it's about a lot more than that. So anyway, just both that article is a very good read, and the Cybernetics Wiki is super interesting to me, at least, and maybe someone else will find it interesting.
Very cool. And yeah, Jessica is a former Ruby Rogues panelist, and she's always got really interesting and smart stuff to share. So
I've read that one. I love it. Yeah.
All right, Mark, do you have some picks for us?
Yeah, I was just going to share, kind of following on this topic we had today. I wrote a blog post last year called People Are Processes. where I kind of dig into some of those ideas that we talked about with encapsulation of state into processes and how that maps to people, and just kind of that whole way that we can think about Elixir systems. So I was just going to mention that as something that people who are newer to this topic can read and kind of go into a little bit more at their own leisure.
Cool. I'm going to jump in here with a couple of picks. Now, this is something, I hate doing this, but I'm going to do it anyway. I'll do one pick of one thing that I've used, and then I'm going to pick some stuff that I'm excited to get tomorrow. So, and that's why I hate doing it. It's because I haven't actually used it. But so the thing that I have used is VRBO. I have found it to be a terrific way to save some money when I travel. So, especially when I go to Las Vegas. Because typically I'll drive down in my truck, and because I live in Salt Lake City, so it's 5 or 6 hours, depending on how the roads are. And
it's a beautiful drive as well.
What was that?
It's a beautiful drive as well. I've done it twice.
Yep. Yeah, it's a pretty great drive. I really enjoy it. My wife and I tend to go down to St. George, which is an hour-ish before Las Vegas on that same road. But anyway, yeah, I wind up in Las Vegas probably 3 or 4 times a year for different events. So last time I went was CES, and I found a really nice studio apartment to be sick the whole time in. This time I'm hoping to have a much better experience, but I just booked another one in Las Vegas. And this one, it's interesting. They actually booked me into a small condo that's part of the MGM Grand campus, I guess. And the conference I'm going to is in the Tropicana, so I have to walk like a block and a half. Anyway, it's really a great way to go. It was cheaper than staying in the Tropicana. I don't mind walking over there, and it's just anyway, they tend to have nice places. I used to go with Airbnb, but I got booked into a couple of places in Airbnb that had some kind of issue one way or the other. I think the worst was when I rented a place in North Las Vegas in a not very friendly part of town, we'll put it that way. And whoever was living in it was a heavy smoker. And so I got in there, and the smell just about knocked me down. And, I don't begrudge anyone smoking, but I don't prefer to stay in places like that, I guess. So anyway, and then I kept hearing sounds outside that made me uncomfortable. So I went and checked into a hotel the last 2 days I was in Las Vegas that time. But yeah, VRBO I've never had a problem with. So
I have to say, I had listing number 93 on VRBO. I think it was in 1995, 1996 when the company had just started. I was still in university, renting out my parents' properties back in Umbria in Italy. So I was on the other side, but right when they were still setting up all the properties by hand, writing HTML by hand. I think Lynn was the founder, and we were corresponding extensively before they got bought up by HomeAway, which is now part of Expedia. So
right.
I've used VRBO, both sides, both as to list apartments, but also as a user. Cool.
Yep. I'll also throw out that the train ride through Umbria is gorgeous as well. So.
Yes.
I haven't driven through it, but I've ridden a train through it. So
that's where you find me when I'm not in London or in America.
Nice. Yeah, it's beautiful down there.
Yeah.
So the 2 things that I ordered that I'm really excited for, I've been getting into video and YouTube some more. And I think I picked on a previous show, and if I didn't, I guess I'll just mention it. But I got a Canon EOS M6, and I got a Rode shotgun mic to go on top of it so that I can record videos when I'm on the go. And I specifically got it for CES this year, and then that was the trip that I was sick in the apartment or in the condo the whole time while I was there, instead of going to many of the events. But anyway, I need some light, so I got some LED lights off of Amazon on the recommendation of Dave Kimura from the Rogues. And then I also got an HDMI input for my computer so that I can hook my camera up to my computer as a webcam, and then I can actually see what's going on. Because the shotgun mic sits on top of the camera, makes it really hard for me to flip the viewfinder up and actually be able to see it because the microphone's right in front of it. So yeah, anyway, I'm excited for that. I also got, what do you call it? I got a green screen as well. So looking forward to playing with all that stuff. Francesco, do you have some picks for us?
I have two, actually. One is Fred Hebert's latest book, so property-based testing with proper, using Erlang and Elixir. And I think this is a book which I've seen him write and grow, and which I think everyone who wants to write well-tested software needs to read and understand. Property-based testing, I think, is an incredibly powerful technique. It's not for the faint of heart, but Fred, in his book, kind of removes the stress and makes it available to the masses. So I really recommend that. And the second is a panel discussion. So I was really lucky to be able to get Sir Tony Hoare, Joe Armstrong, and Carl Hewitt in the same room and get them to start talking about the past, present, and future of concurrency models. I wanted, my main reason was, to get, to go in and document and create a panel discussion, which I think the younger generation of programmers could listen to go in and understand and appreciate, where I think a lot of the ideas and the tools they're using around concurrency models are coming from. And the panel discussion, the transcripts are going to be released this week. And I warmly, if you care about concurrency, I warmly recommend you go in and listen to it. There's some real kind of golden nuggets, which start off with me asking them, what problem were you trying to solve? And and I'll give that away as a spoiler. But you ask Carl Hewitt, he was trying to figure out a model for programming distributed computers. He came out with the actor model. You ask Tony Hoare, what problem were you trying to solve? And he was more or less at the same time as Carl Hewitt. He actually references Carl Hewitt in his CSP paper, concurrent sequential processes paper. He said, well, how do we write programs which will scale on transmuters? So he's basically solving the multi-core, the scalability of, today the scalability of multi-core problems. And third came Joe Armstrong, who knew about CSP but had no idea about the actor model, which came up with the Erlang style concurrency. What problem was he trying to solve? That of fault tolerance. How do you build a fault tolerant system? So, and that's just the first kind of 2 minutes of this panel discussion, which lasts about an hour. And it's a great follow-up. I warmly recommend you have a look at it. The link's available here.
I'm looking forward to that.
Yeah, sounds awesome. All right, well, if that's all we've got, then we'll wrap up. Thanks for coming, Francesco. That was a lot of fun, and I learned a ton. So I'm excited to go back through and kind of re-index a lot of these points.
I really enjoyed it myself. Thank you so much for having me.
All right, well, we'll wrap this up, and we will be back next week. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.